State locking explained. Terraform state records the last known infrastructure mapping. Two writers can read the same state snapshot. Both writers can calculate plans from stale data. Concurrent applies can overwrite state with conflicting results. State locking blocks parallel writes before state changes begin. The S3 backend stores state as one S3 object. The key selects the exact state object path. Locking adds a separate .tflock object besides state. Terraform writes the lock before modifying state. A second Terraform run stops when the lock exists. The buckets must exist before backend initialization. Terraform cannot store state in a missing backend. Versioning keeps prior state objects versions recoverable. Encryption applies at rest to state and lock objects. Public access blocks reduce accidental exposure paths. Terraform reads and writes the state object. Terraform does not require delete access on state. The lock object requires read, write, and delete. Delete access removes the .tflock after apply finishes. Missing lock permissions create false stuck lock symptoms. On a submarine, a tagout blocks unsafe equipment operations. The tag matters only if removal authority is controlled. A Terraform lock follows the same discipline. Weak lock permissions turn coordination into operational drift. Older S3 backends use DynamoDB for locking. The table required a string partition key named lock ID. Current S3 backend locking can use Lockfile. DynamoDB locking is deprecated for this backend path.